3.5, exponential and logarithm models, okay? What was our exponential? Do you guys remember what exponential is? Y equals, and I'll go ahead and just do A e to the bx power, okay? Remember, the exponent is x, correct? Where b has to be greater than 0. Okay. So growth means it is increasing, correct? Yes, okay? So if we look down here, the first graph here is our exponential growth. Again, we will have a horizontal asymptote at what? Y equals 0. Yep. Okay, we cannot cross the x-axis, correct? All right. Exponential decay model, okay, is y equals a e to the negative b to the x power. So b again is still greater than 0, but we have that negative in the front. So now it's decreasing to the right, okay, which is our second graph here. Now, we still have a horizontal asymptote at what? Y equals 0. The Gaussian model is y equals a e to the negative x minus b squared divided by c as an exponent. That's kind of crazy, isn't it? Okay. That one actually kind of looks like our bell curve. Have you guys talked about bell curves before in different classes? Yeah. Yeah, where you talk about z-scores, that kind of stuff. If you ever take probability and statistics, it hits a lot about that with z-scores. Yeah. Oh, yeah. JD remembers that one. Yep. And again, horizontal asymptote at y equals 0. Okay. The logistic growth model, okay, is y equals a over 1 plus b times e to the negative rx power. So in this one down here, okay, we actually have two horizontal asymptotes. Okay, we have a horizontal asymptote at y equals 0 and y equals, in this case, because 3 is in the numerator, is 3. If it was like 4 in the numerator, it would be y equals 4. Okay. Yes. R, negative r to the x. Yep. Yeah, sorry, I moved that up on you. And then the logarithmic models, okay, is our y equals a plus b natural log x, or y equals a plus b log base 10 of x, which are the bottom two here. And in these ones, we don't have horizontal asymptotes, we have vertical asymptotes. And what are my vertical asymptotes? X equals 0. We can't cross the y-axis on this one, right? Cannot cross. Oh, thank you. Oops. Sorry, Mason. Sorry, Mason, I forgot. I have to admit in Zoom. Thanks. You guys help me with that if people come in. All right, any questions with that? All right, so now we're going to look at all of these in story problem sense. Your guys' favorites, right? Is this the blurry page?
Yeah.
Yeah. Okay. Can you read my handwriting then, or is it all blurry?
I mean, I can kind of read it, but
Okay, sorry about that. All right, so I'll go take those pictures again. All right, example 1. So we're looking at exponential growth and decay to start out with here. Okay, the amount S in billions of dollars spent in the United States on a model online advertising in the years 2010 to 2014 are shown in the table. Okay, so here's our how much we spend and what year. Okay. A scatter plot of the data is shown to the right, so you guys see it actually graphed. An exponential growth model that approximates the data is S equals 0.00036 e to the 0.7563 times t power, okay? Where t is in between 10 and 14. And t, again, is our time, right? Our years from 2010 to 2014, okay? Compare the values found using the model with the amount shown in the table. Okay, so right now they have shown us in the table, we're going to use it using the formula. So you guys are going to need your calculator here, and we're going to compare. Okay, so in our model year, okay, so in our year, we're going to use 2010 still, 2011, 2012, 2013, and 2014. Okay, and we're going to look at our spending, but instead of just looking at the table or the graph, we're going to use the equation. And what's my equation? S equals 0.00036 e to the 0.7563 t. So we're going to plug 10 into t. We're going to plug 11 into t, 12 into t, 13 into t, 14 into t, and see what we get. Okay? So let's go ahead and do that. And we're going to round to the nearest tenth because that's what they did in the actual table. So for 2010, I'm going to plug in 10 for t. And can you guys type that into your calculator? So for 2010, what'd you guys get? 0.7. So what do you notice about the table to the actual model? The spending went up, okay? What about in 2011? So change t to be 11 now. I got 0.5, didn't you guys? Huh? I was gonna say, can you hit up and see what you typed in? Hit up on your thing. And I tend to, when I do this, sometimes I miss a decimal. You put 10 again? Okay. All right, for 12, what'd you guys get? 3.1. So in 2011, actually the price did what? Or our spending went down for both 2011 and 2012. What about 2013? 6.7, and that one went down again. And what about 2014? 14.3. So and that one went up, didn't it? So it kind of depends. The model is probably a little bit, like obviously the table is what they actually did. The model represents pretty closely, but not exactly accurate, is it? No. Okay. Right. According to the model, in what year will the amount spent on mobile online advertising be approximately 65 billion? So where would 65 billion go? Or 65? In the S, right? So our S is going to equal 65. Now, can we find our T and solve for our T to see what year it actually takes place? Yeah. So let's go 65 equals 0.00036 e to the 0.7563 t. So what we learned last class on Thursday, how do I solve for e? What would be my first step? To divide by what? 0.0036, right? So I would get 180,555 point, I think it was, wasn't it 0.656, however you want to look at it, equals e to the 0.7563 t. Is everyone okay with that? That's by dividing by the decimal to both sides. Now, how do we get rid of the e? ln, we take the natural log of both sides. And Hunter, that's what we learned, like we talked about last class, okay? So now, the natural log of e to the 0.7563 t is just what? 0.7563 t, right? You guys okay with that? Now, we can type this in our calculator, but right now, just because I don't want to deal with crazy decimals even more, I'm going to leave it as just ln of 180,556, okay? Is everyone okay with that? Now, how do I get rid of the 0.7563? Divide. So I'm going to divide both sides by 0.7563. So t would equal, so now type that into your calculator. Roughly 16, right? So what year will we spend $65 billion on advertising online? 2016. So in 2016, they will spend $65 billion on online advertising based off of that model. Any questions with that? Make sense? All right, carbon dating. I'm going to tell you real quick. The carbon dating model is found by taking R equals 1 over 10 to the 12th power e to the negative t over 8,223. Okay, that is the model for carbon dating. No, I don't have that memorized. I don't expect you to have that memorized either, okay? I had to look it up. Okay. All right. So estimate the age of a newly discovered fossil for which of carbon 14 to carbon 12 is R equals 1 over 10 to the 13th. So if this is the model, where is the 1 over 10 to the 13th going to go? In the R, right? So if we have 1 over 10 to the 13th equals 1 over 10 to the 12th e to the negative t over 8223. Okay, can we solve this? Yeah. How would I get rid of the 1 over 10 to the 12th? Multiply by 10 to the 12th. So those cancel, and I have e to the negative t over 8,223 equals, what's 10 to the 12th times 1 over 10 to the 13th? 1 over 10. Why? Because can't I cross out 10 to the 12th? Because 10 to the 13th is 10 to the 12th times 10 to the 1st. And wouldn't those cross out? Yeah. All right. Now, how would I get rid of the eatable sides? Take the ln. So I'm going to take the natural log of both sides. So I'm going to leave the natural log of 1 over 10 if you guys are okay with that. Equals, what's the ln of e to the negative t over 8,223? Isn't that just negative t over 8,223? Now, how do I solve for t? Multiply by, can I go ahead and do negative 8,223? Yeah. So those cancel. I have a positive t equals, now what's negative 8,223 times the ln of 1 divided by 10? 18,934. So we know the age of the fossil is 8,934, or approximately 19,000, right? Depending on where it asks you to arrive to. I know the book says 19,000. So we're kind of just looking at what we did last class, just putting into story problems, aren't we? Yeah. All right, example 3. In a research experiment, a population of fruit flies is increasing according to the law of exponential growth. After 2 days, there are 100 flies. After 4 days, there are 300 flies. How many flies will there be after 5 days? Okay. So we actually have to do a lot here, okay? And the reason being is because we don't actually know what our A and our B are in our exponential growth, right? What is the formula for exponential growth, real quick? Y equals A E to the BT, right? Power. So for us to be able to find anything, we need to know what our A and our B are, correct? Yeah, okay. Y is going to represent the number of flies. Okay, number of flies. But we have to figure out with A and B to be able to calculate what Y is, don't we? Yeah. So how can we calculate what A and B are? Well, let's think about this for a second, okay? If we know in 2 days there are 100 flies, could I write an equation right here? Do we know what Y represents? Yeah, Y is the number of flies, right? So wouldn't that represent 100 equals, do I know what A is? Do I know my initial? No. E, we don't know what B is, but do we know our time? Yeah, what's my time? T. And what's my T? If I have 100 flies, my T was 2 days. Are you guys okay with that? Could we do the same thing with the next one? If I have in 4 days, there are 300 flies. Could I solve for that? Could I write an equation that way? Yeah. So 300 would equal what? A times E to the B times 4. Okay. Now, from one of these equations, could I solve for A? And it doesn't matter which one, but could I solve for A here? Yeah, and how would I solve? Let's go ahead and just do the first one here. How would I solve for A? How would I get rid of E to the 2B power? I would divide it, right? So couldn't I say A would equal 100 over E to the 2B power? Are you guys okay with that? Now, if I know what A is, could I substitute it into this equation and try to find what B is? Yeah, we could do that, couldn't we? So let's go ahead and do that. So 300 equals, what is my A? What's my A? 100 over E to the 2B times E to the 4B over 1, right? Now, could I simplify that if I really wanted to? Yeah, let's go ahead and simplify this side, okay? So we have 300 equals 100. What's E to the 4B divided by E to the 2B? E to the 2B. Why? Don't you subtract the exponents? Yeah. Now, how would I get rid of that 100? Divide it. So what's 300 divided by 100? 3. So we have 3 equals E to the 2B. And now, how do we get rid of the E? Take the ln. So we have the ln of 3 equals what? 2B. And how do we solve for B? Divide by 2. So B equals the ln of 3 over 2, which is approximately what? You want to tell me what B is approximately? I'm sorry, what? 0.549. All right, is everyone okay with that? Okay. Now, if I know what B is, would I be able to find what A is? Could I find A? Yeah, because what do we know about A? A is equal to what? 100 divided by e to the 2 times B, right? Yeah. So let's go ahead and plug that in. Okay. So A equals 100 over e to the 2 times, and now I'm going to make this a little bit easier. Instead of using the decimal, could I use the exact answer? Could I use the ln of 3 over 2? Yeah, and the reason why I'm doing that is because you'll see here in a second. What happens to those 2's? They cancel out, right? And so wouldn't I just have A equals 100 over e to the ln of 3? Well, what happens to the e and the ln? They cancel out too. So don't we have just 100 over 3? Which is roughly approximately what? 33.33 and so on if we wanted to go. Are you guys okay with that? Now, if I know what A and I know what B are, can you guys write your exponential growth equation? Yeah, because my exponential growth equation is this y equals a e to the bt powered, right? So let's write our exponential growth. So here's our growth model. Y equals, what's my A? What's my A? 100 over 3. And would it be okay if I did the 33.33? Yeah, it's fine. E to the B times T. So what's my B? This one we have to use our decimal. So 0.549 times T. So here is my exponential growth model. Okay. Now, if I know my exponential growth model, could I find how many flies would there be after 5 days? Yeah, because 5 is going to go where? Into the T. So let's find out how many flies we have. So y equals 33.33 e to the 0.549 times 5. So how many flies are we actually going to have? And here on to whole number. So use your calculator, and what do we get here? $520 flies, right? Is that rough? Was that right? 518.8. Okay. So we hit roughly at 519 flies. Okay. I have, if you look at my notes online, I have 520, and it's because I took it out to 4 decimal places instead of 3 for my B. Okay. So the longer you take out that decimal, the better it is, but I'm okay. If you said 520 flies, 519, as long as I knew what your equation was. Okay. All right, any questions with that? Okay. Now, for the bell curves, okay? For example 4, we have to actually use decimals.com, so I'm not going to go ahead and worry about that. But do you know how to graph something using decimals.com? Yes. And then could you scroll over and find the maximum value? Yeah. So you just have to, once you graph this on decimals, you just have to find your max value. So the highest point on the graph. Okay. So I'm going to go ahead and skip that one. All right. All right, logistic growth models. Okay. So the logistic curve is given by the equation of y equals, as we talked about at the beginning, a over 1 plus b e to the negative rx power, where y is the population size and x is in time, okay? Now, on a college campus of 5,000 students, one student returns from vacation with a contagious and long-lasting flu virus. The spread of the virus is modeled by y equals 5,000 over 1 plus 4,999 e to the negative 0.8 t power. Whew. Okay. If you notice, A is the number of students total, isn't it? Okay. Where y is the total number of students infected after t days. The college will cancel classes when 40% or more of the students are infected. Kind of feels like what we're going through right now, doesn't it? I was doing this problem last night. I was like, I wonder when this is going to happen. All right. How many students are infected after 5 days? So where would that go? Where would that 5 go? In T. Yep. Let's go ahead and do A. So y equals 5,000 divided by 1 plus 4,999 e to the negative 0.8 times 5 power. So after 5 days, how many students are infected? $54 students. Yep. Now it says, after how many days will the college cancel classes? Well, what do we know? When will they start canceling? When we affect what? 40% of our students, right? Well, do we know what 40% is of 5,000 students? Yeah, how do I figure out how many students will have to be infected to cancel? I'm going to take 40% and do what with it? Multiply it by what? 5,000, right? So 40% of 5,000, which is multiplication, is how many students? You guys get 2,000 students? So 2,000 students have to be infected before they start canceling. So it says after how many days? So what are we trying to find? T. Yep. So let's plug 2,000 in for y equals 5,000 divided by 1 plus 4,999 e to the negative 0.8 t power. Okay. Now, if I put 2,000 over 1, wouldn't I just cross multiply? Yep. And if I cross multiply, I'm taking 2,000 times this 1 plus 4,999 e to the negative 0.8 t power equals 5,000. Do you really want to distribute that 2,000 through? I wouldn't want to. So how can I get rid of the multiplying by 2,000? Couldn't I just divide by 2,000 and get 1 plus 4,999 e to the negative 0.8 t equals 2.5? Is that better? Instead of having to distribute 2,000 by 4,999, I wouldn't want to do that. I mean, it's not hard, but I wouldn't want to. Now, how would I move that 1 to the other side? Subtract it. So 1.5. Now, what would I do from that? Divide by, so I get by the 4,000, right? So 1.5 divided by 4,999 is, can I just go ahead and leave it as, and not actually do the math yet? Because once I do the math, doesn't it get crazy decimals? I don't like crazy decimals. Okay. Now, how do we get rid of the e's? ln, so we're going to take the ln of both sides, right? And if I take the ln of both sides, I get negative 0.8t equals the ln of this 1.5 over 4,999, okay, which is a decimal. That's crazy. And then how would I get rid of the negative 0.8? When I divide it, so I'd have the ln of 1.5 divided by 4,999 divided by negative 0.8. Make sure when you're using a calculator, you put a parenthesis at the end of the 4,999 before you divide. So roughly how many days would it take for us to cancel? Never. Did you get it? Did you guys get it? 10. Yep, 10 days. Perfect. All right, on a Richter scale, the magnitude R of an earthquake of intensity is given by R equals log base 10 of I over I sub 0, where I sub 0 is 1, is the minimum intensity used for comparison. So really, R could be the logarithm of just what? I, because isn't I over 1 just going to be I? Yeah. Find the intensity of each earthquake. So in Piedmont, California in 2015, the Richter scale said it was 4.0. So could we plug 4.0 here into R? Yeah. So couldn't I have 4, and I'm just going to put 4 instead of 4.0, equals log base 10 of I, right? I don't have to have I to the 0. Why? Because it's just what? 1. Okay. So now, what's my base here? 10. So 10 to what power would equal what? So 10 to the 4th power would equal I, right? Because it's always base exponent equals the exponent is my power, right? So my intensity level would be 10,000. All right, what if my Richter scale was 7.8? So I'd have 7.8 equals log base 10 of I. Right? So what's my base? 10 to what exponent? 7.8 would equal my intensity, right? And so my intensity would equal, what is 10 to 7.8 power? $63 million, roughly, right? Yeah. All right. I'm just going to say 63 million. Are you guys okay with that? Typing all that in. All right. And there we go. All right. Any questions with this? Yes. Are you sure? Yeah. Okay. All right. So a couple things. Okay. On Wednesday, so 11/11, right? You're going to have a quiz, and your quiz is just going to cover the 3.4, actually 3.3 and 3.4. What we learned today is not going to be on there, okay? But again, a lot of this just corresponds with all of that, right? On Friday this week, okay? On Friday, so 11/13, we're going to review for chapter 3. And then that means Monday next week, actually, why did I say Thursday, is review chapter 3. So Monday is going to be what? Your chapter 3 test. Okay, your chapter 3 test.